Okay, good afternoon, Internet. Welcome. Welcome to another NL Mathman Math Help stream. There I am, popping up on the out in the woods next to some zoomies, some doggy zoomies that are going on. We can see a little. Oh boy, boy, oh boy. My chroma key has already. It's uh. It's been a weird day for lighting. I don't know what's going on. I got the windows all blacked out in here and stuff. But for whatever reason, whatever little bit of light is filtering in through the windows is playing havoc today with my chroma key. But I will see what I can do. See what I can do about that little scuffed little bit down in the corner. Let me how about let me try this. Let me try turning this filter back on. Boop. How's that? Now am I gonna get my sweater disappearing on me now? Let me see. So this feature that I've been using, this one, yeah, tends to get rid of the part in the corner back there, right? But now sometimes I'll just start disappearing. Oh, there I go. See, look, there's my sweater. Maybe I shouldn't. Maybe I should make sure to wear a sweater that's a totally different color than the chroma key. Anyway, this is a math help stream, not a stream help stream, right? Although maybe that would be popular. Maybe if I ever learn how to set up a stream properly, I can do a stream help stream. There we go. Now we're talking, right? That's a way to get content, for sure. Over here now, you see we've got some little doggies, Flurry and Smokey out in the woods, gallivanting around. They're having their zoomies. I think this is over near Cormac, on the west coast of the island. My parents have a cabin not far from there, um, somewhere between like Cormac and Hampton. It's a very nice area of the province. If you've yeah, and that's a good thing to mention. Staycations. Dear old Dwight is on the news these days, on the news releases, talking about asking Newfoundlanders to have staycations this year in the province to help our ailing tourism industry. Well, our tourism industry is not ailing normally. Normally, it's very strong, but of course, with COVID, tourism is going to take a blow everywhere. And they're talking about doing staycation, stay at home, and go around in places. Well, let me tell you, down Hampton, Hampton's a really nice place. Great pictures down there, nice country. Um, yeah, and over that way, like Cormac, Hampton, sort of that whole area over near before you get to Deer Lake, is yeah, it's some of the better areas in the province for agriculture too, which is something that we definitely could stand to think about a lot once the dust settles on COVID-19 and we have to prepare for the next emergency response that we have. Because Canada, as a country, we're very food secure in Canada, but Newfoundland, as an island, is not. Or Newfoundland and Labrador, as a province, is not food secure at all. We import a lot. So, yeah, places like Hampton and Cormac and Deer Lake and Codroy Valley and just over that side, we really could stand to yeah, to put some more effort and money into those places and get some domestic grains and vegetables and meats and stuff. Although, my school that I teach at is in CBS, and CBS has a lot of people selling vegetables. You do see it on the side of the road a lot out in Conception Bay South. People selling bags of fresh like stew vegetables and stuff on the side of the road. I know some of my former students actually did that for a bit of extra cash. It's a great idea. I would like to see, say, the government maybe put some effort into encouraging people to do that kind of stuff. Because we need more of that. We do need more of that on the island for once all this COVID nonsense is over. Anyway, this is not we're not here to this is not NL NL idly thinking of what government should do, man. Right? That wasn't elegant. That was belabored. Anyway, yeah, it's NL Math Man for a reason, right? Mega Man, NL Mega Man. Now we're talking. I could. What would you have? You'd have like instead of Metal Blade, it'd be like a slice of bologna. That's a good joke. That's a better joke than you probably acted like it was. Um, yeah. So today I'm gonna do like it says above me here. We got some area of irregular 2D shapes, surface area of regular 3D shapes, and I'm going to do some solving systems of equations. Now, that's actually in the reverse order that I'm going to do them in. I'm going to start from the bottom here with systems of equations because I did have some questions specifically asked me today about systems of equations. So let's get to that. Let's get to that first. So let me zip on over to my working display. Here we go. Now I'll zoom in here. Zoom in, zoom in, zoom in. Here we go. So the question I was asked first about was this number 10. Now I'm going to do a bunch of examples on stream here today because I'm going to work down through part of worksheet 2 and part of worksheet 3 in this course because I'm currently doing up an answer key and correcting some student work on that unit. So it's a good way for me to kill two birds with one stone. But since I was asked specifically about this question, I'm going to get to this one first. So number 10, right, this is, of course is this. Math 1101C, and this is worksheet 4. Getting a little bit of shadow from my hand today. See what I mean? Like even with the windows blacked out, the amount of light that comes through does have an influence on how things look on the screen. Where are we here? So I'm going to do this one two different ways. I'm going to do it. I'll do it first by elimination and then by substitution, just to show the fact that you can do these either way. Worksheet 4, you get to pick which method you want, so you do not need to show both these methods. But yeah, you might gravitate toward one or the other. You don't necessarily need to. Well, you do need to learn both, but you don't have to apply both in any situation like this. Right? So first I'm going to do elimination. And do elimination method over here in blue. So we've got 3 over 4x minus 3 over 5y equals negative 19 over 20 as one of our equations. Then our other equation, I'm going to write it over here on the side of it, is 3x minus 4y equals negative 13 over 3. Now, this one does look quite a bit more complicated than some of the others because of the number of fractions that we have, but the method that we use is still just the same as it is for all the other ones. So I want to get the same for elimination method. I want to have the same coefficient in front of the x as I have in front of, excuse me, same coefficient in front of the x over here as I do in front of the x over here. Yeah. Hey, look, it still works. I'm going to amuse myself a bit. So I'm going to multiply this whole side over here by 4 because I want the coefficient on the x to be 3. So this side is going to be times 4, and then this side is going to be times 4, and then I'm going to end up with 3x minus 12 over 5y equals, let's see, so it's going to cancel, and that's going to become down to 5, so negative 19 over 5. All right, and then from this one over here, I guess I really should have written it over here because I've just kind of wasted a little bit of space, but that's fine. I got paper. 4y equals negative 13 over 3. And now because I want these x's to cancel here, I'm going to go ahead and I'm going to subtract. Oh, I keep making that mistake. The bracket outside here, when I do the subtracting, that's really just to show what's going on. I use that to indicate that I'm taking this full equation away from this full equation. So you wouldn't need a bracket to close a bracket here and open another one here like you should up here, right? Because here you're showing that you're multiplying both sides by 4. Anyway, it's a really small point. So now I'm going to go ahead and subtract. So the 3's are going to cancel on the x's, so we're going to be left with 0x. Over here on the y's, now this is a little bit it's a little bit more work, so I'm going to write it out piece by piece. You wouldn't need to write it out in this much detail when you're doing it yourself. But up here we have a negative 12 over 5 as the coefficient on the y. And down here we're subtracting a negative 4. Subtracting a negative we know is the same as adding. So that's adding 4. And whatever the result of this addition is, that's the coefficient that's on the y. So you needn't write out this part. You could just skip to the next one. But in this case, where we're dealing with fractions, it's a little bit trickier to do. So I'm gonna belabor the point quite a bit here. This is going to be negative 19 over 5 plus 13 over 3, right? Now, there's a lot going on here. So what I'm going to do now is the next step has to be to get these two fractions and these two fractions to have the same denominator. And of course, this 4 here is a fraction. I didn't misspeak there, although I do misspeak frequently. That's 4 over 1, right? Because any whole number is the same as itself over 1. So now I'm going to go ahead and multiply this one by 5 over 5. So we're going to have negative 12 over 5 plus 20 over 5. That's going to be multiplied by the y. And that's going to equal, now this guy over here, I've got a 5 on the bottom here and a 3 on the bottom here, right? So what I've got to do is I've got to find the lowest common multiple of 3 and 5, which I know to be 15. Right? So I had to multiply the top and the bottom here by 3. So I'm going to have, well, 60 times 3, 20 times 3 is 60. And 60 minus 3 is 57. So it's negative 57 over 15. And this one here is going to be times by 5. So 13 times 5 is 65 over 15, like so. Now I can go ahead and crunch these guys, put them together. So this is going to be 8 over 5y is equal to 8 over 15. Right? Because we got negative 57 plus 65 is 8. And then the 15s just stay the same. Now we've got to get rid of this fraction that's in front of the y. So what I'm going to do there is I'm going to multiply both sides by 5 over 8. Right? So again, just to show you what I'm doing, this is not a step you would always write out, but I'm multiplying this side by 5 over 8. And I'm multiplying this side by 5 over 8. And over here, right, on this side, the point of it is that this cancels with this and this cancels with this. That's why we chose 5 over 8. Hi, Saint Just Germany. Yep, welcome. Welcome to the Math Help stream. Thanks for checking in. Over here now, this 8 and this 8 will cancel. We have 15 over 5, which we can cancel down to a 1 over 3. So now we're left with y equals 1 over 3. There we go. Okay, so now we know that y equals 1 over 3 here, and I can go and take that and put it back into either of the other equations over here. So I'm just going to put it into this one up here. So we're going to have 3x minus 4 times 1 over 3. Ah, okay. Hold on a second there. I see that quote there, Saint Just Germany. I will get that's a good one. We make mathematical discoveries, not mathematical inventions. Currently making advances in our understanding of mathematics. We're like jigsaw players piecing it all together. I think that's an excellent quote. Absolutely. I am 100% in the idea that we discover mathematics, not invent it. It's invented in a loose sense in that, you know, people can sort of try it for the first time, can come up with novel ways of combining things in math. But yeah, absolutely. It's a system that sort of already it kind of already exists, and we're just sort of figuring out how these numbers piece together, right? Because when a mathematician, say, discovers, well, sort of invents a new math, say, if we want to use that terminology, they're not really inventing it, because they're just sort of the first people to realize that this math is, that these sort of relations exist and that they're important. So yeah, I absolutely think that we're jigsaw players piecing it all together. Absolutely, that's a really good metaphor for studying mathematics for sure. So I'm just going to carry on now and crunch these ones down. It's going to take a few seconds, but as you see, we already have an over 3 on here, so it's actually a little bit easier now. So 3x, I'm just going to move this over, negative 13 over 3 plus 4 over 3. 3x equals, that's going to be negative 9 over 3. So 3x equals negative 3, or x equals negative 1. There we go. And there's the answer to number 10 in elimination method. It's a little bit more steps than the other ones on this unit, on this activity rather. but it's mostly just because of the number of fractions that we're dealing with. It's all like this and this, right, is what gave us these extra steps that weren't in the other ones. All right, so Betty Ann, I am going to carry on now, and I'm going to do the same one again, but I'm going to do the same one now through substitution method, so you get a good look at how to do it the same way as you would on, say, worksheet 2, right? I won't show you graphing method, at least not right now. But again, right, you know my stance on that one. I very much approve of using graphing technology like Desmos or something to check afterwards. It's a really good idea. So let's see. This is still number 10. Now we're going to use substitution method. So substitution method is going to mean I have to rearrange one of these formulas to get one of the variables by itself. So I'm going to pick this one first, the 3x minus 4y equals negative 13 over 3. I picked this one because it looks easier to work with. So I want to get x by itself. So I'm going to call this 3x equals 4y minus 13 over 3 because I just added the 4 y's over here. Now I'm going to divide both sides by 3, and I'll get x equals 4 over 3y minus 13 over 9. Right? Now I could simplify this a touch, like I can take a 1 out of 3 outside and leave it there, but I'm just gonna leave it like that for now. So now for substitution, right? One of the only wrinkles, one of the main wrinkles in the substitution method is that you have to substitute this one into the other formula. So because I derived this from this formula, I now know that I have to use this one. All right? Just give me 1 second there. I'm going to stand up. My chroma key is going to go bonkers. So just give me 1 sec. Okay. That should give us a little better shadow on my hand. Maybe there's a little less shadow. Yeah, a little less. So let me carry on. Okay. Okay, we've got another quote there. Also read this on Wikipedia. Euler's identity is often cited as an example of deep mathematical beauty. Three of the basic arithmetic operations occur exactly once each: addition, multiplication, and exponentiation. The identity also links 5 fundamental mathematical constants. Um, yeah, I'm not actually 100% sure what that one is off the top of my head, although I will look that one up. Sure, absolutely. Um, but yeah, the whole notion of linking mathematical concepts together is that to me is what really makes math interesting for sure. And I think that you know when you go through math like this, sometimes the way it's taught is sort of like a teach to the test thing. And I understand why teachers do that. I know it's very practical to teach to the test because, face it, students have to write tests, so they had to learn the exact material that you're working on, right? But it's the links between it all underneath that really make math compelling, I think, and really make it interesting. And when you start seeing that, one thing leads to another and how they're all linked together, like the fact that sine waves, these waves like this that we use to represent sound, actually derive from triangles in the Pythagorean theorem. Like it's really amazing that even just something, that we see as two separate different units, if we're saying in high school, and we're looking at, we do Pythagorean theorem now. Okay, from that we do trigonometry ratios, sine, cosine, and tangent, and then we do the waves, like the sine waves and cosine wave and stuff. But the reason why the wave like that exists is because it's describing these relations between triangles underneath it, right? It's yeah, it's really interesting that the more you learn about math, the more you start to see that everything is it's all really connected, and we're just sort of finding out the different interrelations between them. Yeah, it is a very interesting topic for sure. I'll just cross this out down here so when I send Betty Ann these notes, she's just not like why in the world is there like a some hills with a triangle under it? If one part is true, the entirety is true. All elements are dependent on each other. Yeah, yeah, these are good quotes. Yeah, it's great. It's good to be it's good to have some background in the understanding of like the sort of principles of the fundamental principles of math for sure. Yeah, all elements of mathematics are true simultaneously. Yeah, yeah, absolutely, of course. Right? They're true even if like there's new discoveries being made in math constantly. Now, of course, as time goes on, the discoveries become a bit more esoteric and kind of more niche. Like, you know, I didn't do I didn't do a graduate degree in math or anything like that. Like I'm strictly strictly undergraduate in my understanding of some of these things. So I'm really not on the cutting edge for new discoveries. But it is very interesting to see that even when we're finding something that to us is totally new, it was already true all along. It's just we didn't understand it was there, right? Aubrey de Grey solved some very old math problem. He's a biologist, more or less. No, no, I don't. I will Google that for sure. I have to look that up afterwards. I am going to let's see. We'll carry on just jotting down this next one. All right. So now I've got it substituted in here, and I'm going to go through now and start canceling some stuff. Now here you can see why it would have been a little easier maybe for me to leave the 1 over 3 outside here so I could cancel it immediately with this 3. But that's totally fine. So once this multiplies out, these are going to cancel here. We're going to be left with just a y there. This one over here is going to be this 3 is going to cancel with the 9 to be a 1 over 3. And then that 3 is going to multiply by this 4. And it's going to be over 12. So it's going to be y is minus 13 over 12. And then minus 3 over 5y equals negative 19 over 20. Right? So now I know that 1y is the same as 5 over 5y because it's a whole. Right? So if you have 5 over 5 minus 3 over 5, we're going to be left with 2 over 5y. And then I'm going to move this 13 over 12 over. And it's going to be negative 19 over 20 plus 13 over 12. Now again, right, we are getting to this is getting to a rather large situation here where we're going to have, we've got to make this have the same denominator, right? So the easiest denominator to use over here is going to be 60. So I'm going to call this 2 over 5y equals negative 57 over 60 plus, what is it, 65 over 60. Hold on. Where have we seen these numbers before? Where have we seen these numbers before, Twitch chat? What do you think? Negative 57, positive 65? Oh, look, they're right over here. They're right there. Whoa, that's weird. So now I'm going to go ahead and I'm going to draw an arrow up because I'm going to carry on over here because I ran out of space. Let me slide over so you guys can see for sure. And that's going to be 2 over 5y is equal to, let's see, this is going to be 8 over 60, which is the same as 2 over 15. 2 over 5y equals 2 over 15. Now, thankfully now, it's all starting to even out a little bit. It's good. So then y is going to be 2 over 15 times 5 over 2. That's going to cancel there, and that cancels there. This becomes a 1. This becomes a 3. We have y equals 1 over 3. Hey, check it out. Means I probably did something right. Now I can just take this and put it back in up there, which is just the same as with the other method, right? So let's do it as x is equal to 4 over 3 times 1 over 3 minus 13 over 9. So x is equal to 4 over 9 minus 13 over 9. X is equal to negative 9 over 9. X is equal to negative 1. There we go. We got there. 1 over 3, negative 1. There we go. So Betty Ann that should be a good example of how you do question 10 there. And I've gone through it in both the two methods that you're going to be responsible for that unit. Okay, good stuff. Now I wanted to do a little bit more on this topic before I move on, because I'm currently working on, let's see. Do I connect with other math streamers on Twitch? No, I haven't. Haven't been yet. I Yeah, I know networking is a big part of Twitch for sure, right? And yeah, if I want to grow the channel, I would be, connecting with other people and seeing what they do and hanging out in their chats and stuff is really important. Yeah, for sure. Currently, I'm like the FAQ says down below. This is mostly a temporary thing to help my students during social distancing, but I do enjoy the Twitch platform quite a lot. I watch a fair bit of Twitch, like game streaming and stuff, in my spare time when I'm not on here blathering about my classes. Right, so let me now. I'm going to scroll up, and we're going to look at worksheet 2 for a little bit, and then we're going to look at worksheet 3 for a little bit. Now, I'm sure I'm not the only teacher who's using Twitch or other video platforms for teaching their classes. Although mine are, like it says down below, mine are totally optional for my students. This is just a tutorial, right, where they can come and get help, or they cannot. This is not like required classes or anything like that. So, as we see here earlier today, I've been working on a key for Math 1101C worksheet number 2. And this is one, Betty Ann, that you are working on currently. So I'm going to carry on here to show you some examples of how you finish these ones as well. Now remember, this sheet is only substitution method, so I'm going to carry on here using substitution. So for number 7, it's going to be, let's see, 3 over 4x minus y equals 2. Now, substitution method means we want to get one of these terms by itself first, right? So I'm going to try to get the y's by itself. So I'm going to call this negative y equals negative 3 over 4x plus 2, or just y equals 3 over 4x minus 2, right? Then I'm going to go ahead and substitute that into my other equation that I have. Which, for this one, number 7, perhaps I should have left myself more space. We might end up running out of room here. Because this one is 1 over 8x plus 1 over 4y is equal to 2. So I'm going to have 1 over 8x plus 1 over 4, 3 over 4x minus 2 equals 2. Out here like so. Right? So I have 1 over 8x plus 3 over 16x minus, I'm just going to skip ahead and call that a 1 over 2 equals 2. Right? And now I'll skip a little bit here. We know that 1 over 8 is the same as 2 over 16. So this is going to be 5 over 16x is equal to 5 over 2. 2.5. Boy, the camera is really, really showing up as dark today. Wow. I don't know what is going on with this. This is a really old Microsoft LifeCam that I have pointed at my paper here. And yeah, I found it in a drawer after social distancing started, because I haven't really been able to go out and get another webcam. So let me just bump up the brightness there a touch. Okay, maybe that'll be a little bit better. So now I have 5 over 16x equals 5 over 2. So x is going to equal 5 over 2 times 16 over 5, like so. 5 is going to cancel there. 2 is going to cancel with the 16 and make an 8. X equals 8. Right? So now I'm going to take this and stick it back into this formula over here. So I think I have enough space to write that out on my paper. Y equals 3 over 4 times 8 minus 2. Right? So y equals, well, that's going to be 6 minus 2, so y equals 4. There's the answer for that one. I'm going to carry on and do a few more of these. Let's say maybe I'll do another one in this method, maybe 2 or so of the other method, and then I'll switch over to the questions that Ashley had for today. Or that I was intending to do for Ashley's courses for today, I should say. So, number 8, that is 2 over 3x minus 1 over 2y is equal to 4. Okay, now where we're doing substitution method, I'm going to go ahead and switch these around right off the start. So I'm going to call this, I'm going to get y's by itself this time. So we'll call this 2 over 3x minus 4 equals a half y. Or we'll call it 4 over 3x minus 8 equals y. Oh, wow. You hear that? Maybe you can. I don't know, all of a sudden there's some icy sounding rain, or must be freezing rain or something going on outside. So now with the other one in this question, it's going to be half x plus a quarter y equals 5 over 2. So I'll write that half x plus a quarter y equals 5 over 2. So instead now we're going to call this, wow, it got bad outside all of a sudden. Half x plus 1 over 4 times 4 over 3x minus 8 equals 5 over 2. Those are going to cancel there. We'll have a half x plus a third x minus 2 equals 5 over 2. Now, I'm running out of space here a little bit. If I want to use this one for an answer key, I'm going to have to keep the workings rather pristine. So that's a half x is 3 over 6x. A third x is 2 over 6x. So it's going to be 5 over 6x equals 9 over 2. So I've added that over. Right? I'll just put a line down through here so we know that it's new, that's continued on from below. Right? So we'll have x equals 9 over 2 multiplied by 6 over 5, like so. Right? And now, let's see, that's going to be a 1 and that's going to be a 3. So x is now going to be 27 over 5. Yeah, maybe I should have given myself a bit more space to do question number 8. It appears as if we're running out of room. So, tell you what. Yeah, I'll finish 8 down here. You just crammed into this little space as best I can. But then I'm going to have to write that question over when I scan this document and send it in as my answer key. Put it on SharePoint. Let's see. Actually, I'll tell you what. I'll just do it on a different page because I'm running out of space over there. Let me just wiggle around my paper a little bit here, Twitch. There we go. So I'm going to have 2 over 3 times 27 over 5 minus 1 over 2y equals 4. Okay, I wonder if I made any mistakes here. Doesn't look like I did. 5 over 2 plus 2. Yep. Yep, looks good to me. Okay. So now I'm going to go through and let's see, that's going to become a 1 and that's going to become a 9. So we're going to have 18 over 5 minus 4 equals a half y. I'll just flip those two guys around. So we know 4 is the same as 20 over 5, right? So then 18 over 5 minus 20 over 5 is going to be negative 2 over 5 equals a half y, or then negative 4 over 5 is equal to y. Now this one, Betty Ann, if you're still watching, question 8 over here is a really good example of the types of questions that you're going to be forced to deal with, because sometimes teachers are going to be real devious. We're sneaky. We'll pull a sneaky on you. And in a case like this, 27 over 5, that looks like a real monstrosity of an answer, right? If you see this come up, you might think, hey, I must have done something wrong, or it would have worked out to a round number, to a whole number. No, sometimes no. Sometimes the answer is 27 over 5, right? Let me then skip on to the next worksheet and do a few examples out of that one. Okay. So how far along was I on this guy? I was up to question 6. Leave for now. See you another time. Well, thanks for dropping by, St. Just, Germany. Good to have you. Yeah, look forward to seeing you some other time. If you got any questions, you can let me know, or if you just wanna chat and hang out, I'll be here. Be here same time every weekday. Now let's see, number 7. Yeah, I will start off with number 7. So this is Math 1101C, worksheet 3, key, like so. Okay. Question 7. Now this worksheet specifically asks for us to use elimination method. Personally, I prefer elimination method, so yeah, I'm gonna go ahead and do these ones. So we've got 6 x's and 9 x's. We've got 5 y's and 8 y's. Well, negative 5 y's. And we want to get it to be a situation where they have the same coefficient, right? One can be positive and one can be negative, but they have to be the same value. Right? Maybe I should move my. I kind of thought it was neat to have myself leaning outside of what appears to be my window sometimes, but it's a bit odd, isn't it? It is a bit odd. Okay, so for number 7 then, we have 6x minus 5y equals negative 4. And over here then we have 9x plus 8y equals negative 6. So the lowest common multiple of 6 and 9 is 18. So I'm going to go ahead and use 18 because it's the easiest one. So I'm going to call this now 18x minus 15y equals negative 12. I'm going to go ahead and multiply these by 2 and call this 18x plus 16y equals negative 12. Like that. This is looking weird. It's looking a bit weird, isn't it? It appears that the number of y's doesn't actually matter. If the number of y's doesn't matter, what is y likely to be equal to? Right? Well, let's find out. Let's find out. Let's find out what the number of y's is likely to be equal to. So I'm going to go ahead and I'm going to subtract from this one the 18x plus 16y equals negative 12. I'm going to just put a bracket around the whole lot of those guys, like so. 18x minus 18x is 0 x's. Negative 15y minus 16y is negative 31y. Negative 12 minus negative 12 is 0. Negative 31y's are equal to 0. Well, guess what? Y is also equal to 0. Okay? Now I can just go back and stick that into either one of these guys. So we'll end up with 9x equals negative 6. X equals negative 2 over 3. Right? So question 7 was a little bit easier than it might have looked at first, but it is important to know that we will be throwing edge cases at you wherever we can find them. So in this case, uh, you know, the weirdness is that one of the numbers equals to 0. But if you just follow through and do all the steps, it works out exactly the same. So you don't really need to concern yourself with that. You'll figure it out as you're going. Number 8. So we got 4x's, 6y. Oh, well, we got 6 and 9 again. So I'll make the 9s eliminate this time. 4x minus 6y equals negative 1. And we've got 7x minus 9y equals negative 2. Let me get that y to look a bit more y-like. Okay? Now I'm going to go ahead, multiply this one by 3, and I'll have that be 12x minus 18y equals negative 3. Multiply all of these ones over here by 2, and I'll have 14x minus 18y equals negative 4. Now I can put these guys together. So I'm going to be subtracting 14x minus 18y equals negative 4. Have a hail or whatever it was stopped. It stopped just that fast. Just that quick. It started and stopped. So now we've got 12x minus 14x is going to be a negative 2x. Negative 18y minus negative 18y is going to be 0 y's. Negative 3 minus negative 4 is going to be a positive 1. So then x is going to be negative 1/2. Right? Now I can just go and stick it in. 4 times negative 1/2 minus 6y is equal to negative 1. So negative 2 minus 6y is equal to negative 1. Negative 6y is equal to positive 1. Y is equal to negative 1 over 6. There we go. That's it for question 8 there. I'd like to do, let's see, maybe I'll do another 2 of these. Personally, I've got to do, how many more? How many more of this sheet do I have to do? Oh, I've got 4 more to do on this sheet. Okay, so I'll do it a few. And like I said, I'll kill 2 birds with 1 stone. Yay. I do like, of all the problems I'm having with my chroma key, I gotta say, I really like that this pen is the same color as my background. Look at that. I'm like, oh, watch this. This is like Geordie LaForge type stuff, right? No, where am I? There we go. Yeah. So now, oh, never mind. I'm not going to switch back yet because I've got to, the point was to have it be like a pattern, a hatching pattern. So 9, then, we've got a half x, 5y equals 0, 6x, 4y equals negative 14. Okay, interesting. What I'm going to do is I'm going to make it so I only have to multiply one of these guys. So I'm going to do a half x plus 5y equals 0. I'm going to times both these ones by 12. I'll write it out like that. And this will then be 6x plus 60y is equal to 0. Okay? And then from the other one, I have 6x plus 4y is equal to negative 14. Then what I'm going to do is I'm going to subtract. We're going to have 54y is equal to a positive 14. So then y equals, that'll be 7 over 27. Really? That's as low as we're going here? Yep, sure is. Y is equal to 7 over 27. All right, so that's yeah, like I mentioned, sometimes you're gonna get weird looking fractions as your answer, but hey, nothing wrong with that. So I'm gonna go back to the other one. A half. Wait, what am I doing? 1 over 2x plus 5 times 7 over 27 equals 0. So a half x, let's see, is equal to negative 35 over 27. X is equal to negative 70 over 27. Now, that's a bit of an odd looking one, but I did do this correctly, didn't I? Let me go back and check. Only now just getting NL Mathman Twitch notification. Oh, that's too bad, Albert Einstein. Um, yeah, if you're following, which I know you are, you should get an automatic Twitch notification through like the email that you use to sign up, and you should also get one on your Twitch account. I do also, where you're one of my students, I do also send out email ones every day, as you might be aware. I send it out about an hour or so before I go live. I'm going to keep doing those, right? So you'll still get one of those every day, and I'll say what topics I'm covering for that day. Yeah, just to make sure that I did this one correctly. How's about we because this one's a bit of a weird one. How's about we defer to our calculator? Hey, that's the way we do it. If we're unsure about now see where the light has changed. Now look, now my sweater is becoming invisible. Boy, oh boy, I gotta tell you, this has been it's been difficult with that chroma key, but we're making do. We're making do with what we got, and it's mostly just because my background is not it's not an ideal color for sure. So let me switch on over to my Chrome window. Here we go, and bring up my. Okay, let's bring this back up. And now I'm going to type in over here. I'm going to grab my keyboard and move in front of my document cam for a second. Whoa, there we go. So I am going to type in now these two lines that we've got that we were dealing with. And then once I type those in, we will see if Desmos agrees with me or if I'm out to lunch. So 1 over 2. I am out to lunch, but I mean just like in other, with regard to this specifically. Plus 5y equals negative 4 was our first one. Okay, so there's our first line. Oh, you can't see it yet, right, because I've still got the other ones up. Let me add another expression. So let me remove this for you. See, there's our first line. Look at that, right? It's pretty good. The first one. And now let's get the second one here in Desmos as well. So that is going to be 6x plus 4y equals negative 14. I did make a mistake, didn't I? I did make a mistake, didn't I, Twitch chat? Didn't I? Oh, it doesn't equal negative 4. No, it equals 0. Where was I? Oh yeah, that doesn't equal negative 4. Why was I thinking it did? Okay, there we go. There we go. So that looks right. And now let me remove this from here. Now, here's our Desmos, right? And what's it telling us? Negative 2.5 and 0.25. Well, guess what? I guess yeah, I guess I did. I did mess something up, didn't I? Oh my goodness. My goodness, my goodness. There's the mistake. There's the mistake. I knew I would get it. I'd get it eventually. But you see, everybody makes a mistake, especially the teacher. Especially the teacher makes a mistake. Well, it's good. That's a good teachable moment, folks. That's why we do this kind of stuff. Because look at this. I called this 54. That was silly. That was silly. It's not 54. This ain't no answer key now. This ain't no answer key because that wasn't a 54. No, it's a 56. And that, it's the road less traveled by, right? And that makes all the difference. So this is going to be, let's see, that'll be 7 over 28 now. 7 over 28, which means that y will then equal 7 over 28 is the same as 1 over 4. Okay, so now I'm going to have to scrap all the rest of this and do it over for when I want to do my answer key from this. That's unfortunate. That's really unfortunate. But either way, we deal with that. It's part of the job, isn't it? Switch on back over here. Yeesh. Okay. So, but I'll go through now and we'll see that it does work out to be the same as what the internet tells us it is, right? Because you know, you believe a calculator. Don't believe the teacher. So scrap that whole thing, scratch that, reverse it, and that is going to now be a half x plus 5 times 1 over 4 is equal to 0. So a half x is going to equal negative 5 over 4. So x is going to equal negative 5 over 2. And that now works out. Hey, you know, when you're doing hours of math work every day, you're bound to get some wrong, right? Like I get at least one, is what I'm saying. Let me skip on back over to my Chrome window, and then you can see, whoa, no, this is not what's supposed to happen. There we go. Switch on back over here, and we can see, there it is, right? It is right. We get there in the end. Negative 2.5. That's this, negative 5 over 2. That's the same thing. And 0.25, which is positive a quarter. Okay? So the important part is we get there in the end. Sometimes it takes you right up, and sometimes down again. Because it ain't easy. It ain't easy. It ain't easy when you get to what? Something? When you're going down? I don't know. David Bowie. I'm not, you know, I'm sorry, David. I can't remember all your lyrics right off the top of my head. As wonderful as that song is, it's a great tune. Five Horse Johnson does a kick-ass cover of that song too. I like Five Horse Johnson quite a lot. So now let's see. That's probably enough. It's probably enough on that one topic. That's Betty Ann. If you've watched this entire thing, you're a trooper. That was a lot of examples on that topic. I'm going to switch over there now and do a little bit of examples on a different topic that I got ready to help Ashley with her test preparation. So I'm going to zoom on in a little bit here, and I'm going to pick a few of these to go over. Satisfaction, satisfaction. Keep me satisfied. Now I got it ain't easy stuck in my head. Although only snippets of it, right? Because I can only remember like a few words here and there. So it's not even like the full song is stuck in my head. It's just random bits. It's tough, I tell you. It's a trials and tribulations of distance teaching. So this is math 1102A. I believe this is Unit 3 review. It's not the Unit 3 review sheet. This is just some review of the topics from Unit 3. So this question here now, number 5. This is a fairly straightforward one, but I'm still going to do an example of it because it's always good to have one like this to go over, right? And one of the most important things to note here is that you are finding area of these shapes and not the perimeter. Right? Now my drawing is going to be a little off, but that really doesn't matter. Because like I've said a dozen times, what's important on these is the number that we write in. So it's 13 centimeters, 8 centimeters, 7 centimeters, 6 centimeters. Now, if they were asking for perimeter, right? Imagine they were. If they were asking for perimeter, what that is you go around and you add all the stuff up, right? So for perimeter then, we would know that, well, this is 7, so this has to be 6, right? Because it had this plus this, it's got to be 13. So we know that this is 7, and this is going to be another 6 cm over here. We know also that this has to add with this to make 8. So we know that this one here is going to be 2 cm. So the perimeter is going to be 13 plus 2 plus 6 plus 6 plus 7 plus 8, which is going to be 15, 21, 27, 34, 42. 42 centimeters. Right? Just like so. Then, say we wanted to do area though, because area is what they're asking us for. So I'm going to do area in a different color. So to get area, what we've got to do is we've got to find the area of two different sections, right? There's several different ways to do this. We can do a subtraction way or an addition way. Rather than belabor these ones too much, I'm going to do one method for each, and then I'm going to go on and do a different method on a different question. All right, so I'm going to cut it like so. I'll make the green area over here. The area of the green. Well, we know that this green circle here is going to be, it's 6 on the bottom. It's not circle, green rectangle, sorry. Oh boy. 6 centimeters there, 2 centimeters there. So that's going to be 6 times 2, which is just going to be 12 centimeters squared. There we go. Now I'm going to do this over here as the blue area. Right, so area blue equals, well, it's going to be 8 down by 7, which is going to be 56. Area total is just going to be adding those two together. 12 plus 56. It's going to be 68 centimeters squared. Now, the unfortunate thing about doing examples of these ones is that the tricky bit when you're doing these is knowing that this rectangle is 8 by 7, right? If you did 8 by 13 and added it to 6 by 12, then you're counting this area and this area twice. Well, you're counting this area at all, which you weren't supposed to, and you're counting this bit twice. But the real important part for all these guys is going to be to just be able to see after you've split it what the length and the width of each of those individual sections are. Number 3 here is one that I want to get onto. So for number 3, I'll do that in red over here because I haven't used red yet on this page. Oh boy. Wow. All right, my semicircles need some work. I have to go back to practicing those. Um, you know, that's some good like first grade outcomes. Drawing a semicircle, maybe even kindergarten. That's about the level that I'm on for freehand drawings for sure. And they say that practice makes perfect, but let me tell you, I practiced drawing a lot as a kid. I never got super good at it, but you know, it was still fun. I do like cartooning. Cartooning is good. So, the area of the rectangle is going to be 8 by what? How do we figure out the other dimension, right? Because it's 8 across here, but then what's the dimension over here going to be? But if we look over here to where my cursor is, we can see that the radius of this semicircle is 3. If the distance from the center to the edge is 3, then the distance from one edge to the other has got to be the full diameter. The full diameter is going to be 6. So it's going to be 8 times 6, 48 centimeters squared. And the area then of the semicircle, actually as you saw before in some other ones, the way we do the area of a semicircle is just, well, the area of a circle, right, is pi times radius squared. That's up here. So a semicircle is a half pi radius squared because it's half of a normal circle, right? And the radius here is 3. Radius squared is going to be 9. So it's going to be a half pi times 3 squared, or 4.5 pies, which would be tasty. I need some new material, right? 14.14. We'll say 14.14. Hey, look at that. 14.14 centimeters squared. And now the area total is going to be adding those two together. 48 plus 14.14. So that's going to be 62.4 14 centimeters squared. Okay? So that's just showing you how you go about doing that one. Let me do one more example off of this sheet, maybe. Um, this is a good one. Now, actually, these ones here, number 8 and number 7, and number 7, which is this one, and then number 8, which is this one. Those are a little bit more complicated in the way they're written than the ones that you'll be expected to do in your course. The principle is still the same. You're just going to find, say, the area of the circle and subtract the square from it and all that kind of stuff. But the whole like combination of mixed radicals here, like 10 root 2, you're not going to see that. Although it does make the math work out quite evenly, quite elegantly. You're not going to see that on the tests that you're having in this unit. And you see that, yeah, it is. I am not sponsored by Math Aids, by the way. I am not. This is not a sponsored stream. I sponsor them in a sense because I drive, dozens of clicks in ad revenue to them every day. Right? Anyway, it is a good resource. I'll leave it there on the screen. I'm giving them a shout out. But I am going to do question 9 here now. I'll do question 9 because, like I said, I wanted to do an example of a subtraction method for solving these as well. And question 9 now is a really good example of a subtraction method. So I'm going to go ahead and draw out. Yeah, let's keep using my stencil here. Look at that. Across, and then down like so. Okay, so now we know that the distance across here, from there to there, this is 5 meters all the way across like so. So we're told that. We're told that it's 10 meters across the whole bottom. And we're told that it's 4 meters here on this side. So now, there's a few different ways that we could solve this one. We could break it, and we could break this into a triangle and this into a triangle, and then solve. Add this, this, and this together. What I'm going to do is I'm going to treat it as if it was a full rectangle, right? So I'm going to draw a line down here and act now as if this was a full rectangle. It's a bit blurry, isn't it, that 4? The 4 down there in the corner, it's a touch blurry. So the area of the full shape is just going to be, well, it's a rectangle, right? It's a rectangle that's length times width. So it's going to be 4 times 10. The area of the full one is going to be 40 meters squared, like so. Then I'm going to subtract this triangle. So this triangle here, I'm going to do that in blue. So the area of the triangle is going to be a half times the base, which is 4, times the height, which is 5. Right? And which one's the base and which one's the height is not terribly important in the way we organize it, but here we know that 4 is the base because 4 is the distance along this side. And the distance from the base to the peak across here is 5, the same as that. So that's going to be 2 times 5, which is 10. So then the area total is going to be 40 minus 10. Area total is going to be 30 meters squared. So just to show, again, right, like I was saying, actually, there's 2 different ways that we can do any of these compound shape areas, right? This one here, I did this one through addition, and I did this one through addition, right? Because I found the area of this section and this section, added them. I found the area of this section and this section, added them. Down here, this is an example of doing it by subtraction. So I treated it like it was one big shape, and then I subtracted this blue bit that we weren't shown in the first part. But if we scroll down here on our Math Aids one, we see that, yeah, so question 3 checks out. See, correct answer. Question 5 checks out. And then question 9 checks out. There we go. We got there. Right? Math Aids is a really, really useful resource if you need sort of more questions to do. And now Let's see. I've got one more sheet that I wanted to do a few of. I'll just do, I'll do one of each type of shape on here, and then that'll be, we'll call it for the day at that point, I think. But let me zoom in, zoom in, zoom in. There we go. So I'm going to do, I'll start off with question one. I'm going to find the surface area of this figure. So this is still now Math 1102A. This is going to be Unit 3 review. Math 1102A Unit 3 review. Question 1. So here now we've got a rectangular prism. I'm going to draw out a very freehand diagram. To a point that is maybe a bit too close to realistically draw my diagram this way. Hey, not bad. Not bad, right? It's not quite the same way they've drawn it, but I think you can see what's going on here. Right, but we've got 11 cm this side, we've got 7 cm this side, and we've got 5 cm that side. Now we know that surface area is the sum of the areas of faces. Right? Surface area is the sum of the areas of the faces. So we just need to find all these different faces and add those together. So the surface area for a rectangular prism is going to be, well, we have a length times width side. Say this was length and this is width. We have one like that. We have a length, oh, that's height, obviously. We have a length times height, and we have a width and height. It's important that we do each combination, right? So here, if I said the length was 7, width is 11, and then height is 5, right? We know that we're going to, if here we do this, we're going to have each combination. And there's going to be 2 of each of these, as we know, because there's a front and there's a back. There's a top and there's a bottom. There's a left and there's a right. Then after we're done, we're just going to add those guys together. So we're going to have 2 times 7, so 11, plus 2 times 7 times 5, plus 2 times 5 times 11, right? So 2 times 77 plus 2 times 35 plus 2 times 55 is going to be 154 plus 70 plus 110. So that's going to be 264 to 334. 334 centimeters squared, right? Let's go down and see if the teacher managed to do all that math correctly in his head. There we go, 334. All right, so for a rectangular prism, that's sort of all we got to do there. Let me now slide on over. Let's pick this. Is there a better triangle there? Is there a more difficult triangle? No, all those triangles are pretty easy. Okay, well, that's just what this sheet has on it. But I'm going to go ahead and do this next one then. So number 2, this is a triangular prism. We've got a triangle on top. Then the sides extend downwards. And we also have a triangle on bottom. And it's a regular shape, which means it doesn't taper, although mine definitely looks like it's tapering. It's maybe not the most accurate drawings in the world. But, so we know that this is 2 millimeters this side, this is 2 millimeters this side, and this is 4 millimeters here, right? But essentially, very importantly, we were told that these are separated by a right angle. There's a right angle right there. Now, why is that so important? Well, we know that when we're trying to find the area of a triangle, we have to do base times height, right? In this case now, we know that the area of the triangle on the end, uh, well, it's going to be half of 2 times 2, right? Right? So the area of the triangle is going to be, then here on the sides, we've got a half times base times height, a half of 2 times 2, which is going to be a half of 4, which is 2. Right? So we know that the area of this face on the bottom is going to be 2, the triangle face. The area of the face on the top is going to be 2 as well. Well, we've got 2 of those. 2 of them, right? So then this one over here now, right? This is going to be height times height of the shape times 2. It's going to be height of the shape times 2. But then we got another one on back. The other one on back. What's the size of that one going to be? Right? It's actually going to take a little bit more work for us to see this one. Right? Because now we know that, say, if we took this and unfolded it, right? We have these 2 dimensions. This one's going to be 2 by 4 over here. That one's 2 by 4, which is 8 millimeters squared. This one over here is going to be 2 by 4, which is 8 millimeters squared. But this one on back now, what is that going to be? We don't actually know, right? Because say I took this and unrolled it. Say I drew this out as a net. Now a net is a really useful way of drawing these. Like so, right? So we know that this is going to be 4 millimeters all across here, because what I've done kind of now is I've drawn it out as if I took this shape and cut it apart into the sides that it makes up, right? So that's 4 there, and it's going to be 2 there and 2 there, 2 there and 2 there, right? But if I combine them all together, you will notice that one of the sides is different, right? If we look over here, it's a bit clearer, isn't it? It's a bit clearer than the one that I've drawn. That this side of the triangle is 2, and this side of the triangle is 2, but this backside is not. That backside is not 2, and we haven't been told what it is yet. So to find that one, we're going to need to do a squared plus b squared equals c squared, or we're going to need to do the Pythagorean theorem. So we're going to have 2 squared plus 2 squared equals c squared, right? So 4 plus 4 equals c squared, 8 equals c squared, and root 8, sometimes we'll leave that as a mixed radical, but today I'm just going to make it into a decimal. It's going to be about 2.8. So this side is 2, this side is 2, but this side is 2.8, and this one is 2.8, right? Because on the back here, right, this is 2 and this is 2, but this is 2.8 millimeters. And the way we have to find that is with the Pythagorean theorem. So this one turns out to be a touch more work than some of these are, but that's just because we had to find this other measure. So we know that the side on the back in here is going to be 4 times 2.8, right? And if we do 4 times 2.8, it's going to equal 11.2. So the surface area we know is going to be 2 plus 2 for the triangles on top and bottom, plus 8 for this side here and this side here. Then it's going to be plus 11.2 for the side on the back. So that's going to be 10 plus 10 plus 11.2, which is 31.2 millimeters squared. All right, a little bit more than what we were saying. Okay, they did 31.31, so they probably didn't round as much as I did for that, right? Because I rounded mine. My calling root 8 2.8 is rounding down a fair bit, right? 2.83 I could have done. And then 2.83 would have got me closer to the answer that the book is saying, or that the example is saying. So yeah, so that triangle there is actually a bit more complicated because actually the triangles that you see in your book will often be more like this one here. And this triangle here, as you can see, they give you all the information that you need. Right? When you have this one, you don't actually need to come up with any of the sides with Pythagorean theorem because we know this by this is going to be 3.91 times 11. The bottom is 5 times 11. And then this one on the back here is going to be the same, 3.91 times 11 for the other one. And then this is going to be half of 15 for this triangle and half of 15 for that triangle. Anyway, it's a little bit more work. The triangles surprisingly are, but in your course they don't do a ton on those. I'm going to do one more example here now for you. I'm going to go ahead and do number 5. I'm going to do number 5 down here on the bottom of this sheet in black. So number 5 on this sheet then. Oh, that pin is running low as well. My goodness, I am tearing through pins, let me tell you. So let me just rig up a approximation of a cylinder over here. Link that up. This pin is not doing so hot either, apparently. Okay, so from one side to the other through the middle. Oh, this pin smudges easily. Look at that. That's too bad. That's too. I got a big smudge there now. That's going to be 8 millimeters. Well, that's quite a small shape. And this is going to be 12 millimeters up across this side, right? So we know from before from our formula sheet that a surface area of a cylinder is going to equal 2 pi r squared plus 2 pi r h. Right? And I know every single time I do anything with cylinders, I always want to break out a big sheet of paper and tell, whoa, my chroma key. Boy, oh boy. I can't understand how these blacked out windows affect the lighting so much, but you know, I guess my eyes are not the same as a camera, that's for sure. So over here, now we can see we can see it going absolutely bonkers. Never mind. You know what? Twitch chat. I've shown that example of why the derivation of this formula works like this quite a few times, haven't I? But this is the top and the bottom. It's the top and the bottom there. And this is the sides or the lateral area, right? But the only measures we need, as long as it's a regular cylinder, as in it doesn't taper, it's not a cone, all we need is the radius and the height, and then we can go ahead and get the surface area. Surface area here now is going to be 2 times pi times what squared? Is it going to be 8? No, it's not. It's not going to be 8, right? Because 8's our diameter. So we know that a radius is actually 4. 4 squared plus 2 pi 4 times 12. Oh, I'm running out of space. Okay. So the surface area now, 4 squared is 16, because remember, squared means times by itself. 16 times 2 is 32, so that's 32 pi's over here, plus, excuse me, oh, burping again. 2 times 4 is 8, 8 times 12 is 96, so it's 96 pi. The surface area is equal to 128 pi, or the surface area is equal to an approximate value of 128 pi's, which is 402.12. 402.12 millimeters squared. Let's just slide on down. Let's just drop on in. Yep, 402.12. There we go. Spot on. We got it. We got there. Okay, that was some good review for those. Actually, I think that should cover some of the topics fairly well that you were working on for your next test. Oh, stream starting soon. No, it's not. Stream ending soon. Stream ending soon today. So I managed to get through those topics today, no problem. It would leave you with one last little peek at the wintertime frolic of the zoomies when they're off sprinting out after rabbits. They do love sprinting after rabbits, but one of the reasons why Sissy, little sister Flurry, there has gotten a little chubby in her old age is because she hurt her leg pretty bad chasing after a rabbit, or was it a squirrel? I think it was a squirrel actually, because little animals like that like dart from side to side and all over the place. Because to them it's a real serious thing, right? They're being chased by this big monster that's trying to eat them. I don't know if Flurry would eat them or just I don't know. I don't know what she would do if she actually caught one. But she was zigzagging left and right, and she hurt one of her hind legs, and since then it's been um, she's done a lot of like she's had a lot of treatments for it and various things. But when a dog gets older, it's not the same as it used to be. Just one reason little girlies might maybe a little plump. She may be a little plumper than she used to be as a young girl. But she can still grab brother and throw him around. Let me tell you, she's in charge. Let me show. Oh, let me show you. Actually, let me show you. While we're here, just bantering about this. Let me show you a good picture. Now this is a nice picture. You see that? There we go. That's an example. That's an example for you. She's still in charge. She might be she might be like 6 years older than brother, but you know she's still the boss, right? But they love playing like that. It's nothing. You know. Anyway. Well, thanks for joining me today, folks. I hope this was interesting for you, or at least helpful, more so than interesting. And yeah, keep. Hope you're still finding distance teaching to be useful and to be productive. Um, yeah, stay safe. Keep keeping that curve nice and flat. We've been doing great, doing really well in Newfoundland this past little while. So hopefully, maybe the calls cluster scared people straight. Maybe that actually did happen. But we're doing great, and yeah, keep it up, keep your spirits up, and I'll see you again tomorrow.